Okay, today we are going to discuss the assignment 6 of dealing with materials data collection, analysis, and interpretation. So, this assignment deals with the probability distribution. So, okay, let's go to the first question. State whether the following statement is true or false. So, the question is the estimation associated with distribution whose form is not known is called non-parametric estimation. Yeah. Actually, when if a distribution is having some definite form, like a normal distribution where you have this bell-shaped curve, and binomial distribution is a subset of normal distribution, and population becomes infinite, the binomial turns to normal. So these distributions have a definite shape, but when you consider distribution like exponential distribution, it doesn't have a definite shape, like they change with respect to the rate parameter lambda. There are few non-parametric distributions as well, but mostly they are used for the comparison purpose rather than for calculative purposes. And these are more robust. These non-parametric estimations or distributions are more robust, but they are not as effective as like a parametric distribution. So yeah, it's true. Estimation associated with distribution whose form is not known is called non-parametric estimation. But then okay, we'll go to the second question. The expected value of a sample variance for any population distribution, mean, mu, and variance sigma is square is given by. Okay, for this is population mean and it is population variance. The expected sample variance is generally given by the population variance, so which is expectation of s square is equal to sample variance square is equal to population variance square. That's the derivation for this. Not going much deeper into that. I'm just keeping it as like mentioned here. So let's go to the third question. So third question, a population has a mean of 100 and standard deviation 20. Okay, they've given mean is equal to 100 and standard deviation is equal to 20. So population values. The random sample size n is equal to 225 are taken from the population. What will be the mean and standard deviation of the sampling distribution? Okay, they are asking the mean and standard deviation of the sample which we have selected. That is, yeah, now 225 samples we have taken, right? We have to find the mean for them. So, how can we calculate this? Um, First, we can we all know standard deviation of the sample. Sorry, uh, variance of variance of the sample is equal to sigma square, which is variance of the population by n. So variance of the population is 20 square divided by sample size is 225. So variance of S is given by 400 by 225 is roughly around 1.78. So to find the standard deviation of the sample, it is very simple. Just have to take the square root. It is close to 1.33. And one more thing is like population mean, uh, like when when it is coming to population, it's a normal distribution. For normal distribution, the mean of the population and the mean of the sample both remain same, because we are just taking it as a subset from the we are just taking subset. So mean remains mean for not same, I mean mean follows the normal distribution. So mean is same like 100 and standard deviation is 1.33. So let's go to the fourth question. In question number 4, if the sample size, okay, in the previous question, if the sample size was 81 instead of 225, then which of the following statement is correct? Okay, as per that question, like, you can go on. We can answer with this equation itself, and also that I have a pictorial explanation. So sigma of sample is equal to sigma of population by root of n. So when you are decreasing the n, the standard deviation increases. The total standard deviation of the sample increases as denominator is decreasing. So what will happen is like the sample data will be even more spread out than before. So as we are decreasing the sample size, the spread is increasing. As we are increasing the sample size, the spread is decreasing. So here we have decreased the sample size from 225 to 81. So the spread of the sample mean increases. From the mean, the value will be increasing rather than like this. Okay, so fifth question. Let's go to the fifth question. So the following statements about the sample mean and sample variance is true for normal population. Okay, the normal population means a population which follows a normal distribution. So the what are the options they are given is sample mean and sample variance have normal distributions. Actually, sample mean has normal distribution, which we have seen in the previous question, because we are taking that particular sample from the normal population again. So mean remains same, but sample variance doesn't have normal distribution. So the sample mean has a normal distribution. Yes. So sample mean has t distribution. No, it is not true. Whenever the sample size is less than 30 or like even less than that, then uh, th- then it may deviate from the normality. But when the sample size is quite high, they follow the normal distribution. So it is any first three option. From this, we can eliminate the first option. Sample variance doesn't have a normal distribution. So either the sample variance has a chi-square distribution, or ratio of the sample variance to the population variance of chi-square distribution. So sample variance doesn't follow chi-square distribution. Instead, what will happen is like the sample variance to sample population variance. So sample variance is square by sigma square, follows a chi-square distribution where shape is determined by the value n. So n act as a parameter deciding the shape. So as n increases, um, it tends to a more symmetric curve. When n decreases, it turns to a monotonic curve. Yeah, this is the answer. So let's go to the sixth question. If xi denotes any random variable and z denotes a standard normal random variable, which of the following statement is correct? Okay, so to determine that, we have to relate the z. with this equation. So according to central limit theorem, whenever n approaches infinity, the distribution turn out to be normal distribution. So here for normal distribution, z is related by mean of the sample minus the sorry, how it is deviating from the mean. So x bar is the mean of the sample minus mean of the population divided by variance of the population. So this is correct because it represents the standard normal distribution equation. And also, but when we don't know the mean of the sample, expected value of the sample or mean of the sample, then this can also be calculated by this way, like xi minus n into mu divided by sigma into root n. So this has it has both two answers, both A and C. Actually, I have a little derivation for this. Like if you would like to know that, you can um, just mail me. Like in the end of this slides, I will give you the mail ID. There you can send me the mail. I can discuss maybe, or I can give a separate lecture or video upload for that alone. Okay, so let's go to the seventh question. Seventh question is like an electronics company manufactures a certain kind of capacitors. The service life of these capacitors follows approximately a normal distribution with mean equal to 500 hours and standard deviation is 50 hours. If 25 random capacitors are taken, so n size of the sample is n is equal to 25. Find the probability that random samples have an average life of less than 475 hours. Okay, so here they are asking like what is the what is the probability that the average size of the average life of the sample is 475 hours, that is x bar is equal to 475, and mu is already they have given population distribution, that is a population mean, is equal to 500 hours and divided by this is the equation for standard normal variate. So sigma is a uh, standard deviation of the population, which is 50 hours divided by n, square root of n. So n is the number of samples taken. So for that 25 is the n. So when you take the square root of n, it is 5. So it is 25 divided by 10. It is 2 minus 2 point. So if you know the standard normal variate from the table, you can tell what is the probability of it. From this here, like it is minus 2.5. So we can take 2.5.00, which means like it is 0.0062 is the answer. Here we can pictorially represent like this. So this is the mean. So they are asking average house is 500. They are asking what is the mean value, what is the probability that the chosen sample has the average life of 475 hours. So it has been calculated to be 0.0062. So let's go to the eighth question. Okay, before going to that, we need to know some basic details about chi-squared function. So chi-squared function is used to test the hypothesis. Like if you have if you have postulated some hypothesis to test their uh, closeness or how it to validate them, we use this chi-squared function. It can also analyze the goodness of a fit. For example, if you are doing any fitting to the obtained data, the goodness of the fit can be obtained using chi-squared function based on the confidence index. So this is mostly used in this can be this type of functions are mostly used in the EBSD, like that EBSD data whenever it is analyzed um, based on the goodness of the signal which is coming from the sample, it gives the confidence index in EBSD. Like it's one of the application which we are seeing in day-to-day life as a metallurgical engineer. So okay, and the chi-square function shape is defined further by the parameter degree of freedom. So we generally define by n, right? N minus 1 is the degree of freedom. So n is the sample size. So if it has n observation, then n observation in the sense if you're having n independent n variables, then degree of freedom is equal to n minus 1. Those are the independent things which we can vary. Yeah. Then the probability density function of this chi-square function is non-negative, and they are generally skewed to the right side. They're generally like this, as we have seen in the before one. They are generally skewed to the right side, like the tail is on the right side. So okay, coming to the eighth question, if S square is the variance of the sample, random sample of size n taken from the normal population having the variance of sigma square, the statistic this is nothing but psi square is equal to n minus 1 s square by sigma square. This we have already discussed in the previous one. So okay, this follows the psi square distribution, whatever they have given, right? It's sorry. So this is psi square is equal to n minus 1 into s square by sigma square. So this act as the operator which defines the shape, whether it has to be symmetric or non-symmetric. So psi square is it's a psi square distribution with n minus 1 degree of freedom. Coming to the ninth question they have asked: a non-ferrous alloy company produces a premium grade pure copper. They claim that the copper sample they produce has a mean strength. Okay, mean strength is equal to 210 MPa, and with the standard deviation, population standard deviation is 20 MPa. Okay, suppose you have ordered a consignment from this company and chose 25 random samples. So, a number of samples is equal to 25 for the quality of what is the approximate probability that the sample mean will lie between 205.5 and 214.5 MPa. So basically what we have to do, how to solve this question is we know the sample mean in both the cases. So find the standard normal variate of x bar minus mu divided by sigma by root n. So z1 in this case is uh, 205.5 minus 210 divided by sigma is 20 by root of 25 is 5. So it is 4. So is equal to I think it's 4.5 by 4. So Z2 which is 2 on 4.5. It is again, if we calculate it as 4.5. This is minus 4.5. This plus 4.5 divided by 4. So if we calculate the values, minus 4.5 divided by, sorry, 4.5, 4.5 divided by 4. This is 1.125. So it's minus 1.125. This is plus 1.125. So we have to calculate the standard normal variates equivalent standard normal variate values, and if we subtract this z2 minus z1, the probability of given condition is equal to z2 minus z1, which is, we'll find it now. So minus 1.125, right? Yeah. So it is close to 0.1112. We'll keep like 0.111. Yes, yes, Samruta.
Hello.
Yeah,
Uh, Good evening, sir.
yeah. Tell me. You are from.
Yes, sir. I'm from NPTEL. I'm here to monitor this session, sir. I'm not a student.
Oh, okay. Fine.
Has anyone joined till now?
No, generally, in this course, people like so far, whatever I have been conducting, right? People don't join during this live session. I just
Okay.
conduct this session, uh, like I just conduct this
You just
session.
record.
Yeah, I'm recording this. I'm recording this and I'm uploading this in the YouTube, and I'm giving the link to the NPTEL team.
Okay, sir. Okay.
So this is what I generally do.
Okay, sir. Okay. It's okay. I'm just here to see if the scholars are taking the class. That's it, sir.
Okay, fine. Yeah. Then I will go ahead with the session. Like I am already recording.
Yes, sir. Yes, sir. You may continue, sir.
Yeah. Thank you.
Okay. Thank you,
Yeah,
sir. I'll be leaving the meeting.
sure. Okay. So yeah, we were discussing like you have to subtract the z2 minus z1. So we were just finding the z2. Z2 is like 1 second. Minus, yeah, minus 1.125. For that, if you see minus 1.12, it's coming close to 0.1112. So we can keep it like 0.11. So it is 0.11 here, and z2 is 1.125. You have to see in the positive case. Just a minute, let me pull the z table. So here we can see um, what is the value for which we are looking at 1.125 in positive. So for 1.125 and positive, it is coming around so 0.868. We can keep it like 0.87. So in question, if they are asking for three decimal places, so you can keep it like 0.111 and 0.868 here. So just subtract it and get the probability of x being x. Let me keep it as the random variable, x being 205.52 214.5 is equal to 7 5 7 0.757. So this is the answer for this particular problem. So let's discuss the last question. So last question, the mean life of an LED light manufactured by a company is found to be 1350 hours. So mean x bar or mu whatever you keep it as 1350 hours with standard deviation sigma r, sorry, here they are represented as, so we'll keep like a standard deviation is equal to 100 hours. So sample n is equal to sample size of 169 LEDs were taken from this population, assuming 90% of the confidence that mean life of the bulb will lie between. So if we take 90%, if you give 90% confidence to the data, what will be the mean life of the LED? Like we should give the range, because for a normal distribution it should be from the range 90% means it will lie between this. So what is this and this range deviate from the mean? The mean is 1350 hours. Okay, so this cannot be the answer because we have sufficient data to calculate this. So to find the uh, mean value, I mean the range of mean values, we can use this relation where that is a standard normal variate. S is the standard variance of the population. And is the sample size. So here we have variance of the population and x bar and n. We have to find the standard normal variate for the question, given question. So for that, what we can do is uh, z is equal to um, 1 minus confidence index by 2, because like whatever for the confidence index is symmetrical, it's given for symmetry, so we have to divide it by 2 to get the actual z value, like for one particular location. So 1 minus confidence index is 0.9 by 2, so it results in 0.05. So from this, what we can do is uh, we can find the standard normal variate value. So just go to the table 0.05 where we are getting the 0.05 value. Okay, it is this location. So 0.05. So we are getting 0.05 close minus 1.64. Yeah. So that is equal to minus 1.64. So we can use that and we can multiply um, 1.64 into, since it is already having plus or minus symbol, like z value we can take it in a positive 1. Sorry, so 1.64 into, just do the math, 1.64 into 100 divided by square root of 169 is 13. So 164 divided by 13 gives 12.615. So plus or minus 12.615, 1350. This will give you um, values between 1362.6 in the upper bound and 1337.3 in the lower bound. So the close answer is this. So we have discussed all the 10 questions today. So I hope it should be clear. But if you are having doubts, maybe you can mail me mm19d754 at smail.iitmtc.in to this mail ID. We can discuss in person, or I can reply to that mail, or even we can have a separate session to discuss the questions. Thank you.